Okay, well, thank you everyone for joining this talk on behind-the-scenes development in an AI company. The goal of this presentation is to show you some new development roles that have become crucial when building a high-performing AI company. To start off, I would like to use a short example to talk about behind-the-scenes development in general, and then we can dig into it from the AI perspective. So because it's a very visual display of competitive engineering, let's talk about Formula One racing. So there are many factors that determine which team wins a race. It comes down to drivers, pit stop teams, F1 managers, but the F1 car itself provides some of the most important factors to win. Let's simplify it into two most important parameters, so driving performance and reliability. Driving performance meaning how the car handles in corners and how fast it can go on straight lines, and reliability meaning how long the car can run without breaking down. And these are the parameters that the engineering teams working behind the scenes are trying to maximize. What is usually unknown to those who are not F1 fans is that these behind-the-scenes engineering teams can drastically vary in terms of size and range of work they do, depending on the F1 company. And this is because not all F1 companies have the same resources and expertise, which directly affects what they can build on their own and what they're going to have to buy or lease from someone else. A company can have a very small and compact team to assemble an F1 car with third-party components, but it needs a lot more people and expertise to build most of the components on their own. So why would a company invest to build their own components? So it comes down to our two parameters. Teams building most of the components on their own or tightly collaborating with third-party providers are able to optimize these parameters a lot more than teams using standalone third-party components. And this is because engineering teams that have control over more parts of a complex system, such as an F1 car, have more degrees of freedom when developing a performance-boosting feature. So for the sake of this presentation, let's define behind-the-scenes development. It is not necessarily visible to the outside, and it can drastically vary in size between seemingly similar companies. It requires more resources and more expertise, but gives more room for engineers to push the limits of a complex system. Now let's talk about this from an AI perspective using Microblink as an example. So first, just a brief introduction to Microblink. We are an AI company that builds real-time data extraction technology. The main example of our technology is Blink ID. You point the camera towards your identity document and it seamlessly extracts all of its information. So our clients use it as a powerful solution to pre-fill forms, databases, or onboard users remotely. And Blink ID is a part of more than 500 apps and is used by various web solutions. The same technology has been applied to receipts and is now scanning around 300 million receipts a year to enable advanced market research. The product is called Blink Receipt and has been developed in tight collaboration with our partners in the US. Actually, the first challenge we tackled with AI back in 2016 were handwritten math equations. So this is now a separate company called Photomath that is aiming to revolutionize education. And with more than 30 million active monthly users, they're scanning more than 1 billion math problems each month. And we do business all around the world, and our technology reaches more than 100 million end users. So the data extraction market is our track. And again, our success is dependent on the whole team. But our core data extraction technology provides some of the most important factors to beat our competition. The two most important factors for us are the accuracy and the speed of scanning. Accuracy being a measure of how robust the system can be when extracting data in challenging real-world conditions, and the speed of scanning being the key metric that enables advanced user experience. And these are the parameters that our research and development teams working behind the scenes are trying to maximize. When we take a closer look at our Blink ID product, this is its AI system that performs data extraction. So it connects to a camera and outputs structured information visible on the identity document placed in front of it. And you can see that it's a complex system that consists of many parts. But it's important to point out that the same as in the Formula One example, an AI system can be designed and implemented with a small and compact team using standalone third-party components. And in Microblink, we chose to go the other way and invested heavily in our infrastructure and expertise to build our own components. And this allowed us to squeeze out significantly more performance from our AI system. In the remainder of this presentation, I will be taking you through some of our crucial AI system components and the development roles needed to build them. So let's dive into the details. The system actually consists of several AI models. One question that may arise here is why not train a single AI model? And the short answer is that this is not a straightforward task where current AI models excel, and therefore it makes sense to cleverly design a multi-model system. But the important thing here to note is that we want to maximize the accuracy of each of these models in order to maximize the final system accuracy. So let's have a look at the process of developing one of these AI models. It's a data-driven process, which explains data being in the center. And here we're talking about supervised machine learning, which means we need labeled or annotated data to train and evaluate our models. So this is why the first step in developing an AI model is annotating your data. And the crucial thing to have when building highly accurate AI models is highly accurate annotated data. The principle defined by an IBM developer, garbage in, garbage out, states that computers simply process the data they're fed. And we would add that there are levels of quality here to consider. And for the highest level of accuracy, you need to invest in your own data management system. Which brings us to our first crucial system in the AI development process. So there is much more to annotating data than it seems at first. You need to understand your domain before you start annotating, and our data management system supports our team of domain experts to handle this. As for annotation, it needs to be efficient while providing the highest level of quality. Our system allows us to maximize these parameters to a degree that would be very hard to achieve with a third-party provider. And these have been our conclusions after extensively testing against both crowdsourced and private company annotation services. The development team building this system consists of many important development and engineering roles. So their users are actually data experts and annotators, and they work closely with AI engineers. The system is built with .NET Core microservices using Docker and Kubernetes, and we use different databases for different purposes, and the same goes for front-end frameworks. Okay, so now that we can rely on high-quality annotated data, we can start developing our AI model. So the standard pipeline is to train and evaluate the model on some data, and then if we are satisfied with its performance, we can deploy it. And there are great open source tools to do this. We are using TensorFlow for production and sometimes PyTorch in the research phase. The problem arises when you start doing this on production scale, where currently in our case we are talking about around 15 AI models in production that are constantly being updated on new data. So that's thousands of instances of the aforementioned standard pipeline, and the AI engineers may handle this at first, but as the number of production models rises, this becomes very difficult. I actually took this term production scale machine learning from Google, and there are many other companies offering their solutions to handle this. But for us, it ended up being the same decision as with the data management system. We can go a step further by building our own system. Which brings us to our machine learning engine. So back in 2016, it was very obvious that the open source machine learning tools such as TensorFlow were merely just tools. And we required something that enabled our whole AI development process. So the engine was developed to connect to our data management system, which allows for easier training of our models, but also enables pre-annotation with our best AI models to maximally speed up our annotation. And it also gives our AI engineers a place to build their repository of proprietary neural network layers, architectures, and training procedures. And its goal is to handle the production scale, which includes large-scale model training, evaluation, and automatic deployment of the models. The roles needed to build out this engine are a mix of software and DevOps engineers. They work closely with AI engineers who are actually their direct users. So for development, we use mostly Python with emphasis on TensorFlow, on top of which we are building our engine. And since we are building a machine learning pipeline, there is a lot of novel DevOps tech being used in this process. So now that we have all our AI models trained with the highest possible accuracy, the question is, how are we going to run each of them? And this highly depends on the platforms you wish to deploy the final system on. In our case, we are talking about cross-platform, which means that the best way, in our opinion, is to implement the model inference engine in C++. And again, there are some very good open source solutions for this. Google TensorFlow Lite and Apple's CoreML would be at the top of the list. But back in 2016, when we were deploying our models on mobile phones, those didn't exist. So we started building out our own AI inference engine. And fast forward to 2020, the numbers speak for themselves. So this is our latest benchmark performed earlier this year, and it runs our production AI models across a dozen representative mobile devices. As you can see, we significantly outperform TensorFlow Lite on low-end and mid-end Android devices, and we even managed to outperform Apple's CoreML on their own iOS devices. And a part of that boost in performance lies in the fact that we are optimizing our needs while open source engines are optimizing everyone's needs. And even if we were not faster than the third-party alternatives, it would still make sense to invest in our own inference engine. So firstly, cross-platform coverage is guaranteed, and we do not rely on decisions of companies that have competing platforms. Secondly, control over privacy of the models is something that is becoming more and more apparent as a serious issue. And from our experience, it's very risky to rely on a third-party provider to handle this. Multi-model support, both speed and memory-wise, that makes a world of difference when you are running a whole AI system on device, is another very important benefit. And finally, this gives us a platform to build on top of with our own innovations that can drive new products. So the engine is implemented by C++ developers experienced with hardware level optimizations using the latest C++ standards. But there are also other roles needed to achieve the performance I showed you. One important example to mention is our benchmarking system that is implemented using Python, Rust, and SQL. So now that we have the models trained and ready to run with our inference engine, we have to put it all together to form an AI system that performs a complex task. So each of the models was designed to solve a particular task, and some tasks are handled by processing units implemented by product developers. Also, it is important to have control over the parts of the system where crucial or product-sensitive decisions are made. The problem that neural networks are black box approaches can be alleviated to a degree in a complex AI system if you design it in the right way. And the final system is exported, in our case, as a static C++ library with everything including the AI models compiled in. The team responsible for building this system consists of C++ developers, some of which are very experienced in computer vision. Essentially, they're doing product development with AI models on their disposal. And same as with the previous team, they care about being on the latest C++ standards, and they utilize compile time and meta programming. And this brings us to the last step of our development process. So the deployment of our AI system on both mobile and web platforms. For mobile, one component that has proven to be crucial is our custom camera management system. And this system controls many problematic camera implementations that happen mostly on Android. Our deliverables are SDKs that are developed for iOS and Android, and they are auto-generated using our code generation tools for cross-platforms such as Cordova, React Native, and Xamarin. So we emphasize simple UX with new platform-specific features. On web, we want to offer our technology across all channels. So the AI system is wrapped in a Docker container to be set up on-premise or be used as a service. And currently, we are working on a new and very challenging in-browser scanning experience where our web product developers are working closely with the inference engine team. And this brings us to the final product that on mobile looks like this. So the user needs to simply point the camera towards its identity document, and the AI system seamlessly extracts all of its data. So there are actually 8 AI models working in parallel in real time to enable this kind of user experience, and it's all done on device. So every step of our AI development process and every system and development role I showed you was needed to achieve this level of performance. If we decided to build our BlinkID product using third-party components, this would be a completely different product in terms of accuracy and speed of scanning. So I hope I showed you that there is a lot of cool development going on in an AI company, and that if you're a developer, there's a big chance you can play an important role in AI. I will be now joining you in chat for any questions. Thank you for your attention.